This is part 2 of the walkthrough of the Oneway ANOVA, looking at the relationship between tanning and happiness. In the last video, we summarized the data. We've got 3 groups here: a group that gets a tan with sunscreen, a group that gets a tan without sunscreen, and a group that gets no tan. Here's the data that's summarized, and in the last video, we calculated the 3 basic ratios. So now we are ready to calculate the sums of squares. Our first sum of squares is our sum of squares A, and the formula for this is basically the basic ratio for A minus the basic ratio for T. All right, so we've got 638 minus 533.33, and this equals 104.67. Let's kind of cut off there, 104.67. Our next sum of squares is our sum of squares S over A, and the formula for this is the basic ratio for Y minus the basic ratio for A. So we've got 654 minus 638, which equals 16. Our last sum of squares is our sum of squares T, and the formula for this is the basic ratio for Y minus the basic ratio for T. So we've got 654 minus 533.33, and this equals 120.67. And again, I always encourage you to actually do this on your own calculator. So if I'm going too fast, just pause it, plug those numbers into your calculator, and make sure that you're getting the same numbers I am. And don't forget to round to 2 decimals. So we've got this 0.333333. So we had to chop off some 3's, so we're going to have to do some rounding throughout this problem. Before you move on, you want to make sure that you do the check. So your sum of squares A plus your sum of squares S over A should equal your sum of squares T. So make sure that that checks out. Also, your sum of squares should never be negative numbers. So if you get a negative number here, you've done something wrong. More than likely what you've done is you've reversed these symbols. You've reversed the basic ratios somehow. All right, once we have our sums of squares, we are ready to calculate our degrees of freedom. This is arguably the easiest step of the problem. We're going to have a degree of freedom for each one of our 3 sums of squares. So first we have our degrees of freedom for A, and the formula for this is simply little a minus 1. So going back to the beginning of the problem, our little a is 3. So 3 minus 1 is 2. Next, we're going to do a degrees of freedom for S over A, and the formula for that is little a times the quantity, n minus 1. So our little a is here. We already said that was 3. Our little n is 4. So we have 3 times the quantity, 4 minus 1, which is 3 times 3, which is 9. And then finally, we have our degrees of freedom T, which is a times n, no parentheses, minus 1. So we have 3 times 4 minus 1, which is 11. And again, there's 2 checks that you can do at this step. First, you want to make sure that degrees of freedom A plus degrees of freedom S over A equals degrees of freedom T, which it does. The second thing that you want to do is look at this degrees of freedom T. Our degrees of freedom T should always be 1 fewer than our total number of observations. So we have 12 observations in here. Our degrees of freedom T should, in fact, be 1 lower than that, and it is. It's 11. Once we have our sums of squares and our degrees of freedom, we are ready to calculate variance. But remember, in the ANOVA, we refer to variance as the mean square. All right, so we are going to calculate some mean squares. Remember, the overall formula for variance is the sum of squares divided by a degree of freedom. We have 3 sums of squares here, and we have 3 degrees of freedom. So technically, we could calculate 3 mean squares. We could calculate variance 3 different times. But we actually only need 2 of these. So the first mean square we are going to calculate is the mean square A. And this is really simple. All we're going to do is match up the sum of squares with the corresponding degree of freedom. So our mean square A is our sum of squares A divided by our degrees of freedom A. So it's 104.67 divided by 2, and that equals 52.34. We're going to do the same thing for S over A. So our mean square S over A is equal to our sum of squares S over A divided by our degrees of freedom S over A. So our sum of squares is 16 and our degrees of freedom is 9. So 16 divided by 9 equals 1.78. We could calculate our mean square T, but we don't really need it for anything. These things don't add up. There's really no way to check at this step. The numbers should be positive numbers, but beyond that, there's really no way to check. So we usually don't calculate the mean square T. Once we have the mean square A and the mean square S over A, we are ready, finally, after all of this, to calculate our F ratio. And our F is equal to our mean square A divided by our mean square S over A. And remember what these things refer to. Our mean square A, this is our between subjects variability. It's looking at how the means of the groups compare to one another. And our mean square S over A, this is our within group or our within subjects variability. So it's looking at the variability within the group. All right, so we're just going to plug these 2 numbers in. So our mean square A is 52.34. Our mean square S over A is 1.78. And so when we calculate that out, it equals, I'm going to rewrite that because that was messy. It equals 29.4. All right, so that is the last calculation. Our F ratio in this problem is 29.4. The last thing that we're going to do, and I tried to leave myself some room here, is we are going to end with our ANOVA summary table. All right, so our first column is source, sum of squares, degrees of freedom, mean square, and F. And really all we do on the ANOVA summary table is we're going to summarize the numbers that we just calculated. So our sources are A, S over A, and T. And this is not magic. It's basically the little subscripts on your sums of squares and on your degrees of freedom. It's the little subscripts we've been calculating all along. And just to remind you of what these are, A is the between subjects, S over A is the within subjects, and T is the total. All right, so once we have the columns and the rows lined up, we are literally just going to plug in all the numbers we calculated. So for our sums of squares, A was 104.67, S over A was 16, and T was 120.67. Our degrees of freedom were 2, 9, and 11. I usually draw this line here. Our mean squares were 52.34 and 1.78. And our F, which we're going to put in the first row here, is 29.4. And that is the end of the second walkthrough of a one-way ANOVA. Now, we still need to figure out what this number means. What do we mean by 29.4? And we're not quite ready to do that yet. But next week, I will be explaining to you what that number means and how we can figure out whether that means there's something going on here or not.